What up? Told you what you're going to see on your test. 4 of the 6 topics you've prepared for. There's going to be an implicit derivative. There's going to be a piecewise function. Something that you haven't prepared for. But I'm telling you that it's going to be on the test. So um, let's do the problems that could help us prepare. I told you there's 2 implicit derivatives from like the past 10 years and 1 piecewise function. I'm going to start with the piecewise function. 2012 number 4, and I'm going to add a bunch of parts to it based on what I think they could ask you if you're given a piecewise function. This is 2012 number 4. It's a no calculator problem because it's number 4. And they don't really hit up the piecewise function until part C. They give you this guy. So like part A is not really a piecewise function. It's really an easy question. It's an implicit derivative. There's an O and an I. I mean, I'm sure those of you who are actually watching this video, like you know how to take a chain rule derivative, and I don't have to show you. But if there is one of you out there who's actually like studying and you forget about the O's and I's, that's what we do. All right, and like you leave it like this. Honestly, it's fine. It's free response. If you want to simplify, you can. Write an equation for the graph of the tangent of f at x equals 3. X equals negative 3. Negative 3 squared is 9. 25 minus 9 is 16. Square root of 16 is just 4. It's not plus or minus 4. So I get y minus 4 equals some slope x plus 3. The slope comes from the tangent slope generator, which I just found. Again, this is easier than what we see. So I am going to cross some stuff off. Plug in negative 3. The opposite of negative 3, so that's a positive 3, over the square root of 25 minus 9, which is the square root of 16, which is 3/9, which is 1/3. Wait, 3/4. Yikes. Yep. Okay. Now we get to the piecewise part. And this is where I'm going to add some stuff. Okay? So let's do part D first. What's the value of this? Again, like they don't ask you this anymore. They like put this, you have to do this inside of something else. This is a use substitution guy. You ready for use substitution? I guess I'm not there yet. Either figure it out or use substitution. U equals 25 minus x squared. Du is negative 2x dx. Negative 1 over 2x du equals dx. If I plug in 0, this turns into 25. If I plug in 5, this turns into 0. X root u 1 over 2x du. X's cancel. Anti-derive. U to the 3/2 times 2/3. The 2/3 and the 1/2 cancel, so it'll be just 1/3. I could find the change from 25 to 0, or I could go back and go 0 to 5. Sorry. Go back to x's. I'm a little bit off right now. 0 to 5. Again, you don't have to have stuff simplified. You get, 0 minus negative 1/3, 25 to the 3/2. That's plus a positive. That's your answer. Leave it like that. Okay? If you plug in 5 and 0, you get the same thing. All right, great. So that's part D. Let's go to part C, and we're going to just start really talking about different questions. All right, let's talk about the actual question. Is the function continuous at x equals -3? Use the definition of continuity to explain your answer. Definition of continuity is that a function is going to be continuous, and g of x will be continuous at x equals -3 if g of -3 equals the limit as x approaches -3 of g of x. What's the function value, and do we approach it from both sides? Uh, g of -3 is the same as f of -3. We found f of -3, it's just 4. Okay? Um, the limit as x approaches -3 from the left of g is what I have to do to prove that the limit exists. I already showed that we have a function value. Now we have a limit, and we have to prove that the limit exists. This is literally like the more intense way to check if you plug in -3 into f little 1 and -3 into f little 2, and do they meet up with each other, then you're continuous. That's what we've done for multiple choice questions. Like, does f little 1 at -3 equal f little 2 at -3? And like we've done this, and like plug in plug in -3 into f, and I got 4. Plug in -3 into the other guy, and I get 4. And it's like, yeah, we are. They won't accept that. You won't say like, hey, like the top piece gets it. Like you got to use limits if they ask you this on a free response. They've kind of gotten away from this. I'll show you other types of questions. And literally, you just have to say the left-hand limit equals, f of -3, which is 4. And then you say the right-hand limit, the limit as x approaches -3 from the right of g of x, equals, and you can literally just say like -3 plus 7, which is 4. So then you say yes. If you see something about continuity, that should discuss. What else can come from piecewise functions? So I'm going to give you something that's like really like tricky. I think it shows up on your test, honestly. And like that's what's the area under G from -5 to 5? Okay. Now, if you understand piecewise functions, you should understand like what I need to do here. And a lot of people, we mess up. We try to use everything all at once. Like if I give you this question, and g of x, first of all, you got to understand what you have. There's g of x, is a piecewise function. It should make sense to you that since we're only using f from -5 to -3, that's what I would have. From -5 to -3, I'm going to look at the area under f. I'm going to change up the question. Let's pretend you go from -5 to 0, and this goes from 0 to 5. Okay, because I'm thinking ahead here. So, since I'm only using f from -5 to 0, I got that. And then I'd have to add from 0 to 5 the area under this. Okay, and I got to do this all myself because I don't have a calculator. Well, I think that something like this shows up on your test. And it's not nice. It's very cruel. This question. Very cool. Because you always know that when you take an integral and you don't have a calculator, you should take the antiderivative, right? Just take the antiderivative. And a lot of you are thinking, okay, I'm going to take the antiderivative. But then you're thinking, oh, I'm going to have to get rid of this like derivative of the inside. And you might be thinking like there needs to be a negative 1 over 2x. It's wrong. If I think this is the antiderivative, then I'd have to use the product rule. If I use the product rule, I won't go back there. And it's like, huh. And then some of you are going to think that, oh, I just have to take the antiderivative of 5 minus x because you square rooted 25 and you square rooted x squared. You can't do that. Come on. That's just like telling me 5 plus x squared is 25 plus x squared. It's not. Same goes with any power going over addition. It's not easy to just distribute the power. You can't distribute the power over addition. So then, what the heck is going on here? How can I figure this out? Well, did you know that x squared plus y squared equals 25 is the equation of a circle with a radius of 5? Because it's like x squared plus y squared equals r squared. Did you know that root 25 minus x squared, the positive half, would be the top half of the circle? The circle is a radius of 5. Okay? So that means we're going to be going from negative 5 to positive 5. The positive root, and I'm sorry, and I think this shows up on your test. The positive root is just the positive half of the circle. I don't see this ever. This is, I think, cruel. If I'm going from negative 5 to 0, I have this area. What's that area? I'm sorry. It's 1/4 of a pi times 5 squared. How do I find that integral? By understanding what the graph is. But listen, you could do that for other things. X plus 7 from 0 to 5. X plus 7 goes to 12. Starts at 7. Look, this is x plus 7. Y equals x plus 7. Okay? So if I ask you, hey, what's this? I actually don't have to take the antiderivative because it's just like a trapezoid worth of area. 1/2 my width times the sum of my heights. So I get 19 times 5 halves. Okay? Now let's pretend like you didn't know that. Obviously, you didn't know the one on the left. I don't think I showed you something like that all year. Again, they're getting crueler and crueler these days, but we just got to deal with it. Do the best we can and get the points that we can get. If you were to take the antiderivative, you get 25 halves plus 35. I'm telling you, it's the same as that trapezoid's area. Taking that, adding that is your area. So, but what's the key to this? Well, first of all, splitting it up, making sure if it's find the area from negative 5 to 5, you better go and say f is from negative 5 to 0, and then x plus 7 is from 0 to 5. I'm sorry, this is cruel, but you have to know that this is an equation of a circle, and then this would be a quarter circle. You don't have to simplify. Now, what if they asked you, hey, what was the average G from negative 5 to 5? I would just do the same thing that I just did. It would just be 1 over b minus a. Integral from a to b of what I'm trying to find the average of. Okay? I'm looking at the test right now. keep talking about G. So we talked about continuity of G. We talked about areas under G. We talked about the average of G. What if I asked you about the average rate of change of G from -5 to 5? That's another question. Well, remember, average rate of change is like, you can either look at like the average G prime if you want to, and do 1 over b minus a and it go from a to b. But it's actually a lot easier if you do an average rate of change is as a slope of a secant. They are equal. Average G prime is the same as the average rate of change of G. They're the same. But it's easier for me to just do like, what's G of 5 minus G of -5 over 5 minus -5. We had something like this on our quiz. You just got to make sure you plug in the right stuff into the right equation. If I plug in 5, 5 plus 7 is 12. And that's why I'm plugging in 5 into this piece, not into both pieces. So you got to make sure you understand what a piecewise function means. You use one for these x's, you use the other piece for the other x's. You never use both at the same time. You could check when we leave one and pick up another at the important x value. You could check at the important x value if they meet up. That's the only time that we use both at the same time. So G of 5 is 12. G of -5 is f of -5. F of -5 ends up making this 0. And then 5 minus -5. So you get 6/5. So there's another type of question. All right, last one. What is the absolute maximum value of G? Okay, and again, G is the piecewise function. Well, since this is a piecewise function, this is what you have to do. You have to look at when G prime equals 0 or your endpoints. This includes the comparison of the endpoints for F and the endpoints of G. I probably would instead of saying this blanket statement, again, the free response test has become more like, do you really know calculus or not? The absolute maximum value of G is going to be I will have candidates of the absolute max of F from -5 to -3, or X plus 7 from -3 to 5. So when F prime, I have a question for you before you leave. The square root of 25 minus x squared, the integral from -5 to 0. Is that a fair question?
Oh, totally fair.
I know, but
yeah, you got to know you are expected to know that the graph of the square root of a squared minus x squared graphs a circle centered at the origin with radius a.
Is that in our
well, if it's not
it's
in
a
the course
pre-calculus.
description,
It's a pre-calculus.
Yeah, if it's not in the course description, then it is clearly an expectation based on prior exams, items that we've seen. As recently as the 2019 one.
I didn't see it in 2019. I saw it in 2012.
Well, no, it's on the free response. That piecewise function, that might be BC only, but that terrible, are we paused?
No, we're not paused.
Okay, well, that's
okay.
I didn't much like that question, but it was a piecewise, it was a piecewise function.
All right, I'm going to pull that question up next.
Yeah, that's what I would do.
2019 BC number something?
3.
All right, cool. It's not the practice, it's the actual released. Oh, that's the one that
It's the one that the lady had the video of just that one problem.
Right. I had her take it off, but that's the one that they're having. That's why I'm getting them ready for that problem.
Oh, yeah. Then they got to do it.
I'm telling you to get ready for that problem. All right, so -5 to -3. Or when x plus 7 has a derivative that equals 0, which it doesn't. It's like, or the max of x plus 7, which is at the endpoint. This is a horrible explanation. 12. Well, x equals 5, and then g of 5 is 12. But I'm going to say that, or the max of x, which is at endpoint, x equals 5. Well, I'll say g of 5, which equals 12. That's easier. Why? Because I know g prime from -3 to 5 is positive. G prime is just 1. Like we have a straight line. I mean, it's easier. Okay. So really what I have to do is actually look at f and look at its maxes and mins from -5 to -3. And I went back to -3 instead of 0. Now, we already found f prime. This is a weird question. I mean, I'm giving you a weird question. And that's -1 over root 25 minus x squared. And it's like, when does this equal 0? And it doesn't. When x equals -5, it's undefined, which means we have a vertical tangent. If you think about it, if you're talking about a circle, over here is a vertical tangent, over here is a vertical tangent. I'm going from -5 to -3. Since I know it's a circle, again, I know it's increasing. So if it's increasing, why is the derivative negative? The x stays silly. Okay, so that's the derivative of f prime. It does have a 0 at 0. We could do a sign analysis of f prime. F prime between -5 and -3, plug in anything, -4. It's a positive over, this will be a positive. So that's a positive, okay? So f prime is positive, that means f is increasing. So the candidates really are g of -3, because f prime is positive from -5 to -3, and g of 5, because g prime is positive from -3 to 5. It's telling me g is increasing from -3 to 5, -5 to 3, and then g's increase. Really, like the endpoint's going to be at 5. I don't know if I have to compare. On your test, you're going to have to look in the middle as well as the outsides, unless you can say why you don't look at the middle. Since we know this function is continuous, we actually don't have to do this. Like, since g is continuous, and g prime is positive from -5 to 5, g of 5, which equals 12, is the max. If you know that there's no jumps, and that's the thing that I'm worrying about, is like on your piecewise function that you're going to get, might be a jump. If there's a jump, you got to check your endpoints at your jumps and check your signs of your two things. Compare them all. Pretty brutal. This one's not the case. I don't have to check the endpoints because I already know that it's continuous. I know G prime is really positive and then positive, like, and since it's positive and we're continuous, like, I know that's got to be the max because G has got to be increasing the entire time. Like, this is the whole idea of like, when do we not have to worry about when derivatives equal zero? It's like, if we know the signs are consistent, we can just talk about the endpoint. But for you guys, for your test question, I fairly pretty much guarantee that you got something where like we have one piece and then we're going to stop and then we'll pick up another piece and we'll stop, and maybe this is a little excessive. Maybe it's like this. And then pick up another piece, and probably one of these pieces is like the equation of a half circle or something like that. So if I ask you, like, where's the overall max? It's like, well, I got to check this endpoint. I got to check this, though I could exclude this if I talk about the signs of the derivatives. I need to check this, this. You know, you got to check everything. So there's lots of candidates. All right. So I don't know. I don't think it's a tough question, but hell, free response test is getting harder. Maybe you have a piecewise function coming up. Now let's look at the other type. Implicit derivatives. Okay. I did 2015 number 6 on your last homework video. I'll do it again, but I'm going to start with 2021 number tough question. Like, I'm telling you, if you look at 2021 and if you try to do 2021, like, number 1's really hard. Number 2's not bad. But yeah, number 2's not bad. Number 2's like you got to get 8 or 9 points on number 2. Number 3 is like wicked hard. Number 4, you got to do well on number 4. But look, it's like they threw in a L'Hopital's rule where you have to take the derivative twice. They threw in a mean value theorem question. They really have one question where it's like, when is the graph concave up? They didn't even talk about like an absolute max or a min. You don't even have to find areas at all for this. Anyways. And then we get number 6. Number 6 is a differential equation. You know, you hope to see this. I would move the 12 minus y, leave the 1/3. But anyways, let's go to number 5, differential equation. I did this in some of the classes, but making sure you're ready for this. Okay. More recently, in the practice test you're about to take, on the 2021 test, they've been bringing up these implicit derivatives. And I feel like they want to use questions like this more often because it's a free response question that comes from the first half of the class, the first semester. Most of our free response questions come from the second semester, but it's like, hey guys, first semester can have some free response too. Part A is to show that the derivative is that. You literally have to just take the derivative, show the steps that take you to there. They give you the answer. They pretty much have to give you the answer because if you don't get this answer right, you have no chance of getting anything else right. So like they're hooking you up in that They're telling you what the answer is going to be, but you got to show them how to get there. Now remember, whenever you take a derivative of y, you need a dy dx after it. Remember, if there's a product, x times y is the most common product. You got to use the product rule. Derivative of the first times the second plus the derivative of the second times the first. Okay? Now we go through the process of like moving everything with a dy dx onto one side, leaving the stuff without a dy dx onto the other, factoring, and dividing to solve. Four cos y, y cos x over 4y minus sine x. Computer froze. It's great. Y cos x over 4y minus sine x. Okay, great. You just got, a couple points. Write an equation for the line tangent to the curve at the point 0, root 3. Great. Hopefully we've done this enough with differential equations and other situations that we realize like dy dx is a tangent slope generator. You plug in y's and x's to get tangent slopes. So I get y minus y1 equals, I'm going to find the slope in a second. The slope is not that equation. Don't make that mistake. You plug in root 3, you plug in 0. You can leave it like this, it's fine, but it's easy enough to write that cosine of 0 is 1, that the sine of 0 is 0, and that root 3 over 4 root 3 is 1/4. Let's say you don't. Doesn't matter. Okay. When do I have a horizontal tangent? This is important. Dy dx is 0, horizontal. Dy dx equals undefined, vertical. 0 over a number is 0. Undefined is a number over 0. Don't forget this. I don't know what it is on your test, but I know it's implicit, and I know they're asking you for a horizontal or a vertical tangent. Okay? So all we care about is the top equaling 0. They make sure to remind you, y's are positive. If y's are positive, we cannot have a 0 coming from y times cos x. We can just have x coordinates. Now, when x is pi over 2, guess what? There's no way around. You need to know that the cosine of pi over 2 is 0. 3 pi over 2 as well, but we're talking about 0 to pi. When x is pi over 2, we have a horizontal tangent. I'm not done yet because it's find the coordinates of the point. I have an x coordinate. I need the y coordinate. How do you find a y coordinate? You go back in and plug x equals pi over 2 into the original equation. And boy, they're just throwing people for a loop here. And they haven't done this in the past. You end up with 2y squared minus 6 equals y times 1. This is a quadratic that has an a that doesn't equal 1. We haven't factored any of those all year because they rarely show up. But they do here. If you don't know what to do, use the quadratic formula. If you have a technique, use that technique. If you can figure it out like I usually do, because I don't like teaching techniques because techniques are forgotten, but distribution always stays. You got to think about it. You got 2y times y. Okay, I need some set of numbers where I'll get a -6. So I'm thinking 3 and 2 or 6 and 1. That's not bad. But then they have to add to get -1 when I distribute the 2y to that number and this to that number. So it's 2y times or 2 times b plus 1 times a has to equal -1. That's not bad, actually, if this works. And then a times b has to equal -6. Let me see if I can solve. I literally am just trying this. Um, I'll solve this in a second. Let me just try to figure it out. So I want. It'd be great if I had like. If I do 6 and 2, that doesn't work. 2 and 3. Okay. So -3 times y is -3y. 2y times 2 is +4y. I'm going to switch my signs. That should be positive. Okay. Now let's see. Can I solve that this way? 2b equals -1 minus a. A times, no, let's solve for a. A equals -1. No, it's just going to go back in the other direction. It's going to, like, we're going to end up with this equation. Yeah, it's not. No, it's not. No, you just have to do like a number puzzle. It doesn't work out. You end up getting that quadratic. Anyways, we figured that out, which tells me that my y coordinate is -3/2 and +2. Since my y's are positive, my y is only 2. So my point is pi over 2, comma 2. Okay? So they made that a little tougher. And then part D comes around. Determine whether f has a relative min or relative max or neither at a point found in part C. I'm going to show you something, guys, for back in the day. 5.2. We were finding horizontal and vertical tangents of implicit curves. We were practicing derivatives. If you want practice on implicit derivatives, here we go. 5.2 homework. We had these questions here. The second derivative test. Okay? Second derivative test allows you to find a max or a min, and this is on the quiz 5.2. Second derivative test allows you to find a max or min by examining the concavity of your curve at the location of a horizontal tangent. -1 is a horizontal tangent on the original curve. By examining the concavity of the curve, tell me if -1 is a max or min. We can't do a sign analysis of a derivative if it has x's and y's. Because it's like, well, like, how are things changing? It's like a two-dimensional sign analysis. We like things to be like on a one dimension, just like x's left and right, not x's and y's. That's too complicated. So we actually use a second derivative. We take a second derivative implicitly and plug in -1, and we get a second derivative sign at a point, but that point is the point of where we have a horizontal tangent. If you know the second derivative is negative, you have a max. With implicit derivatives, and if you see this second derivative test is very important. This was usually only asked on BC students, on the BC test, and then it showed up on the AB test. Do you have a max, a min, or a neither for part C? Well, I can't do a sign analysis because I have y's and x's. Even though like 4 times y is positive, sine x can be a max of 1 or a min of -1, but like for y, if y's are positive, there's a problem there. If y's were bigger than 1, I would know that 4y minus sine x is always positive. But since y could be like 0.00001 minus sine, all of a sudden that could be positive or negative. So what we have to do is take our derivative and look at the second derivative, because you can't sign analyze dy dx with x's and y's. Okay? So, how do we get the second derivative of this? It's like, it's going to be messy and it's going to be long. And they're making you really believe in yourself. And it's like, I know I have to find the second derivative. You look at the scoring guidelines, just Google it. You'll see. It's like, oh, yeah, they did. This is what they did. I have to use the quotient rule. Within the quotient rule, I have a product. Derivative of the top is the derivative of y cos x, which is the derivative of the first times the second, plus the derivative of the second times the first. That's the derivative of the top. Use a big set of parentheses of that. Times the bottom. Okay. Minus the derivative of the bottom. They'll give you a lot of space for this. Put that in a big set of parentheses. Times the top. Glad I wrote small there. All over the bottom squared. You are figuring this out at pi over 2, 2. Now, you know that my first derivative at pi over 2, 2 is 0. Think about it. Plug in pi over 2 for x. The cosine of pi over 2 is 0. 4 times, okay, whatever. 0 divided by anything is 0. Who cares about that? Okay? So that helps things out, because now I can say, okay, this is 0. I got to figure out what this is. We have a 0 here. I got to figure out what that is. All over whatever this is squared. Okay? Some other things that are nice. The cosine of pi over 2 is 0. The cosine of pi over 2 is 0. The cosine of pi over 2 is 0. Now, this is one of those situation guides where if you tried to leave things like unsimplified, you won't know if it's positive or negative. You could guess. You'd be like, I hope. But you might have to simplify this to see if it's positive or negative. Now, you know the denominator's positive, right? It's almost like we don't really care about this. Sine of pi over 2, again, is 1. So I have negative 1 times 2. So this is negative 2. I got 8 minus 1, which is 7. I got a bunch of zeros. And I have 8 minus 1 squared. So that's 7 squared. So I get negative 14 over 49. I had to do that work to figure out that, since the second derivative at pi over 2 pi is negative concave down at a horizontal tangent, max. You don't have to state anything like that. You just say pi over 2 pi over 2 comma 2 is a max by the second derivative test. If you get an implicit question, be ready for the second derivative test. Maybe not. Now let's look at the other Piecewise 2015 number 6, and let me see, because I made the video for these problems like a year ago or 2 years ago. I don't even know. Let's see if Yeah, it's like you could tell this is older and that they've gotten harder. Like 2021, they said, "Hey guys, can you please find the second derivative and just plug in -1 for me?" It's like, sure, thanks for the directions. Instead of, "Hey, tell me if that's a max or a min." Oh, guess what? You had to remember the second derivative test, which has never been asked before on the AB exam. It's only been asked on the BC exam. But we're making things harder, so you got to just know what to do at all times and be able to do it. Yeah, sorry. Concepts, not processes. It it's changed from a process kind of driven type test to a like you got to know concepts. Equation for the tangent line. I mean, again, yo, these days it's not, it can be shown that these days part A is show that. So I don't know if I did this on the video, but do it now. You need to do the show that step. Show that this derivative is y over 3y squared minus x. You got to show for implicit derivatives, you know how to take a derivative. This is a common thing. The minus xy. You can either bake in the negative x or leave it out. I like to bake it in. That way I'm just dealing with plus and I don't have to distribute a negative. So that's negative x times y. I have a product. I have to use the product rule. Derivative of the first times the second plus the derivative of the second times the first. Where did I go? There. Derivative of the first times the second plus the derivative of the second times the first. A lot of people forget how to take the derivative of xy. That equals 0. I add the y to the right side. I factor out the dy dx on the remaining terms. I divide to solve. You need to be able to do that. So if you have not, go ahead and practice implicit derivatives. Now find the equation for the tangent line. That's easy. Y minus 1 equals an m. An m comes from a tangent slope generator. 1 over 3 minus 1, that's 1/2. This is like, I mean, they don't make questions like this anymore. I don't know. Maybe I'm wrong. Maybe we're gonna crush things. Maybe the test is gonna be easy this year. Just have a feeling so. Find all the coordinates of the points of the tangent line is vertical. This is when, okay, good. We're taking our derivative and setting the denominator equal to 0. The problem with our denominator equaling 0 is I don't know. Like there's an infinite amount of solutions, but turns out there's not. Remember, you get this very same question on your test. This must be true for all my points. This must be true for all my vertical tangents. It's a system. What do we like to do with systems? Solve for one variable, substitute it into the other equation. We need to do that. And this is a good question you may see on your exam. Wherever I see x, replace it with 3y squared, giving me y cubed minus 3y cubed equals 2. Negative 2y cubed equals 2. Y cubed equals -1, which means y equals -1. Find the points. You could go back into the original equation, but it's easier to go back into this. Like, again, it's a system. We've already plugged in one into the other, so this must be true. When y is -1, x has to be 3. So 3, -1 is the location of the vertical tangent. Hey, why don't you find the second derivative? I mean, all right, at least something that's consistent. Implicit curves, second derivatives. Either to figure out if it's a max or min or not. Why don't we do the second derivative? No. there's no maxes here. There's no horizontal tangents. Why don't we just find the second derivative here for practice? So y over 3y squared minus x, that's right there. Okay, so we take the derivative of my first derivative. The derivative of the top times the bottom. The bottom is not a product, so we're good. So when we take the derivative of the bottom, it's just 6y dy dx minus 1 times the top all over the bottom squared. We're plugging in negative 1, 1. We've already plugged in negative 1, 1 for part A, and we got a half. Don't forget that. This was dy dx at negative 1, 1. So dy dx at negative, I need to put a half right there. I need to put our half right there. I plug in 1 everywhere else. So I got negative a half. I have 3 times 1 minus negative 1, so that's plus 1. I have minus 6 times 1 times a half minus 1 times 1. It's so annoying when you got ones and negative ones. Just plug it in. Over 3 times 1 squared minus negative 1 squared. I'm done. I am not simplifying that, right? Holy cow, am I not simplifying that? Did they ask you to simplify that? No. Did they ask you, are we concave up or concave down? No. Do you need to know if that's positive or negative? No. Please utilize that to your advantage and make it harder for me to grade. But you know what? That's the deal. Okay? So like piecewise with that crazy square root 25 minus x squared idea of the equation of a circle, cruel, but it's showing up on your test. Continuity, areas, splitting it into pieces, maxes and mins, looking at endpoints, especially if you have jumps. Implicits, being able to take the derivative. Horizontal, vertical tangents, whether you find the value easily or you have to, use a system. Being ready to take second derivatives. I feel like, hey, we're ready for those two types of questions if you watch this video and you pay attention. Okay? All right. Peace.